Spot testing basics. Spot testing is a necessary part of identifying lichens accurately. It is also fun and easy. In fact, you might find that most of the effort is getting in the habit of using the tests. Spot tests are used because lichen species contain many unique secondary metabolites. In a positive test, changes in color will occur, caused by chemical reactions between the secondary metabolites and the chemical test. This flowchart, put together by Bruce McCune, provides a great overview of what secondary metabolites can be detected using chemical tests. There are four main reagents used for spot testing, which are abbreviated as I, P, C, and K. The I test, or IKI test, uses iodine potassium iodide to detect starches. The P reagent, which is short for paraphenylenediamine, comes in a powdered form and needs to be mixed with ethanol before each reaction. The C reagent is household bleach, and the K test is potassium hydroxide. Iodine potassium iodide and C reagents are relatively harmless substances, but KOH and P require a bit more caution and care while handling. KOH is corrosive and can cause chemical burns if it comes in contact with the skin and can be especially damaging to eye tissue. It can also damage hair and clothing. If KOH does come in contact with anything other than your lichen, be sure to use soap and water to clean the impacted area. In the unlikely event that it gets into your eyes, immediately irrigate your eyes with water and continue to irrigate for at least 10 minutes. P reagent also requires caution, as it is a contact allergen and can cause varying degrees of irritation in any tissue exposed. Some individuals are highly sensitive to P and may experience dermatitis, throat irritation, and bronchial asthma. The most common use for paraphenylenediamine is as the active ingredient in dark-colored hair dyes and as a henna substitute. If you know you're allergic to hair dyes or henna, it might be best to limit your exposure to P as much as possible. The P reagent also stains everything it comes in contact with. Therefore, it's not uncommon to find small brown stains appear around your work area after using P. The powder can easily volatilize in the air, so limiting exposure and reducing the mess requires care. Lastly, P is a carcinogen and can be lethal if large amounts are ingested or absorbed through the skin. While it might seem intimidating to use K and P reagents, if used properly, there's very little risk of harm when using them for spot tests. Now that we've learned all about the chemical reagents, let's look at some other supplies you might find handy while performing your spot tests. A dissecting scope is especially handy while working with small samples. Forceps, scrap pieces of paper, and a razor blade are also necessary. Glass capillaries are required for P testing, and it is always a good idea to have separate waste containers for your spot test waste. Lastly, tissue wipes and gloves are great for keeping your workspace clean and reducing any unwanted exposure to any of the chemical reagents. Now that all the basics are covered, let's see some spot testing in action. The first reaction we will look at is the eye test. The first step of any spot test is to expose the tissue that you want to be testing. In this case, we want to expose the medulla. Next, we will drop a small amount of the IKI solution onto a piece of scrap paper or onto a microscope slide. You can see the IKI reacting with the starches in the paper as it turns bluish black. Let's see how the reaction looks up close. Here you can see the medulla immediately turning blue, indicative of a positive reaction. Another method of spot testing is by using glass capillaries. This method can be useful if you're testing lots of samples at once. Let's see this and an example of the K-test on a piece of xanthoria. Let's see that reaction up close. You can see this reaction is immediate, and that beautiful purple color on the cortex is indicative of a positive K plus P reaction. Sometimes, if you have fewer samples, it's easier to just use a piece of scrap paper and a drop of the reagent. We already saw what a K plus P reaction looks like. Here's an example of a K plus Y reaction on the cortex of Physcia. This is also a pretty quick reaction, and you can see the cortex clearly yellowing. The last example of a K reaction is the K plus Y fading to orange. Here you see the medulla quickly turning yellow, but after a few seconds it darkens into orange. If it's not obvious right away, try rewatching the reaction at a faster speed. The C-test is performed in the exact same way as the K-test. You can either use a glass capillary for this reaction, or you can use this method using a piece of scrap paper and a drop of the reagent, depending on whatever works best for you. Did you see that disc turn bright red? Let's look at that up close. This reaction initiates immediately and then quickly fades. Our next example of a C-test is a C plus Y, or a C plus yellow reaction. The next spot test we will look at is the KC test. This test can be done by using glass capillaries or by using drops of the reagents on a piece of paper. However, the most important thing about this reaction is that you use K first and then C. Let's see that reaction up close. In this reaction, we also get an initial K plus Y reaction on the cortex. This one's a lot more subtle than the previous one, and you can see a quick flash of yellow on the cortex, which eventually fades into a sort of green color. This is pretty common and something you might want to look out for, as some of these reactions are pretty quick and can fade pretty quickly also. The KC reaction we're looking for is on the medulla, and you can see a quick change to red This reaction will also fade, but much more slowly. Here's another example of a Kc plus R reaction. Using P reagent requires slightly more effort than the other tests, since it needs to be dissolved in ethanol before each use. It is also important to limit your exposure to P, which can be easily done by using a tool to scoop a small amount of P out of the vial, rather than dumping it into the inkwell, which could result in a big mess if too much P comes out. Also, be sure to keep the lid on the vial between use. Once you add the ethanol, wait a second or two, and then pull the mixture into your capillary and test your lichen. It's just that easy. Some reactions are weaker than others. In this case, we have a P plus pale yellow reaction on the cortex. Did you see it? Look here. Now try looking for it again. Our last example of a P reaction is a P plus yellow to red. As you can see, this reaction develops quickly and quite dramatically. When all your P testing is done for the day, it's important to clean your wells and your work area using ethanol. Be sure to dispose of any tissues that came in contact with P in a separate container. I like to use a plastic sealed bag. Thank you for watching this video. I hope it answered some of the questions you might have had about spot testing, and I hope that you have a little bit more confidence as you move forward with lichenology and using spot tests with your IDs. If you want any more information about getting spot testing materials or just learning about lichens in general, make sure to visit the Northwest Lichenologist website.